In section 1.2, we're looking at intercepts, symmetry, circles, and some key equations that we'll use throughout the semester. First of all, remember for an x-intercept that our y value is always equal to 0, and for the y-intercept our x value is always equal to 0. Symmetry-wise, when we have something that is symmetric to the y-axis, so here's our y-axis. Symmetric to the y-axis would be like a parabola that comes down, touches at the origin, comes back up. Again, we can move up and down the y-axis anywhere we want, but to be symmetric to the y-axis, we're saying that if we have something like y equals x squared, then we also know that y is equal to the opposite of x squared. So for example, if we have a point over here like negative 2, 4, we have a point on this side, 2, 4 shows that symmetry. For the x-axis, if we're looking at parabola coming this way, this is a graph, for example, of y equals the square root of x. We're looking at positive and negative square root of x. We also then have the opposite of y is equal to the square root of x, showing us our symmetry there. We also could look at symmetry to the origin. So when we're looking at that, we're saying that our coordinates x, y, if we're having symmetry to the origin, then be equal to the opposite of x and the opposite of y. And so something that comes along this direction and comes here, like y equals x cubed, that's what our graph for y equals x cubed would look like, where each coordinate here, then we have the opposite of x, opposite of y, showing that symmetry. Other key graphs that we'll use, y equals 1 over x. Remember, we have asymptotes at the x and y axis here, so that would be our graph for y equals 1 over x. And y equals x, we just have a line coming across here going through the origin where our x and y values are all the same. When we look at circles, remember our standard form for a circle, x minus h squared plus the quantity y minus k squared equals r squared. That's our standard form, and we're saying that hk are the coordinates of the center of our circle. R is the radius, and then the point xy is any point on the circle. So this formula comes from the Pythagorean theorem. It comes from our distance formula, and so we're saying that the radius squared is equal to, here we have difference in x value squared plus difference in y value squared, just like we have with distance formula. Now general form, we have x squared plus y squared plus ax plus by plus c equals 0 for general form of a circle. Now if we have a circle with a radius of 4, and then the center point, hk, has coordinates at 2, 3. Alright, so if we wanted to write the equation in standard form, then we're going to say that we have x minus 2 squared plus y minus 3 squared equals 4 squared, or 16. So that would be our equation in standard form. Now if we want to go ahead and square this quantity, we would have x squared minus 4x plus 4. And if we square this quantity, so we have y minus 3 times y minus 3, remember to use FOIL, we would end up with y squared minus 6y plus 9. And this is all still equal to 16. So now if we combine our like terms, bring the 16 over, we can now write this equation in general form. So we would have x squared plus y squared minus 4x minus 6y plus a negative 3, or minus 3, equals 0. So there would be our equation in general form. Now if we wanted to graph this, we know we have our center at 2, 3, so I go over 2 up 3. And then we could count off points from there. For the radius to be 4, I could go back 4 here. 1, 2, 3, 4. That would be a point on the circle. I could go down 4. 1, 2, 3, 4. That'd be a point. I can go over 4, and I could go up 4 to find these other points to give us our circle. Nice pretty circle. And we could, if we wanted to extend this, we can find these x and y intercepts. If we go back to our standard form of x minus 2 squared plus y minus 3 squared equals 16. If I wanted to find the y-intercept, I plug in 0 for x. So that'd be 0 minus 2 squared plus y minus 3, again quantity squared, equals 16. So 0 minus 2 is negative 2, we square that, so we have 4, right? So I'm going to move that over to this other side, so we end up with y minus 3, that quantity is squared, is equal to 12. Take the square root of both sides, so y minus 3 is equal to square root of 12. And then we can, that's going to be a plus or minus 12. Bring the 3 over, so our y values would be 3 plus or minus square root of 12. And that would give us our points on the y-axis where x is 0. We could also then do the same thing to find our x-intercepts, where we plug in 0 for y and then solve.